So today's class I'll start with the first module, Laplace Transform. So transform in general, it means change. So you have learned transformation from Cartesian coordinates to polar coordinates. So you know that y equals f of x is the Cartesian equation of the curve. So every point in two-dimensional space is identified with the ordered pair xy as well as r theta. So for every point you have the equation in Cartesian form as well as polar form. So Cartesian curve y equals f of x, polar curve r equals f of theta. So the transformation is there only to make things simple. We have the concept transformation in mathematics only to make things simple. So the simplest transformation is Cartesian form to polar form. So x equals r cos theta, y equals r sin theta, and r equals root of x square plus y square, theta equals tan inverse of y by x. So you know the transformation from Cartesian to polar form to Cartesian form, and any transformation is possible if and only if the Jacobian is non-zero. Any transformation is possible if and only if the Jacobian of xy with respect to r theta is non-zero, or you can say the Jacobian of r theta with respect to xy is non-zero. So for every Jacobian you have the inverse Jacobian. So you know that j dash is 1, that is product of Jacobian and its inverse is 1. So that's what you have with respect to the differentiation. So you have the transformation with respect to differentiation. So similar to differential transforms, we have integral transforms. So one of the integral transforms is Laplace transform. You have learned Fourier transform. The Fourier transform is also one of the integral transform. So integral transform, from by the name you can understand that it will have an integral. So let f of t be a real valued function. So what is a function? It is a relation between two or more things. So you have, see, there is a relation between you and myself. I am a faculty, you are the student. So a function is nothing but a relation between two or more things. So f of t is a real valued function. Real valued function means f of t takes only real numbers. So real numbers contains natural numbers, whole numbers, integers, rationals and irrationals. So let f of t be a real valued function defined for t lying between 0 and infinity. So suppose that for a complex or a real parameter s, the integral 0 to infinity e power minus st f of t dt exists. So we have taken a real valued function f of t. You multiply this function with the kernel e power minus st, and you integrate this with respect to t from 0 to infinity. You integrate this product with respect to t from t equals 0 to infinity. So this integral, if it exists, it is called as the Laplace transform of f of t. So we are taking a real valued function f of t. We are multiplying the real valued function with the kernel e power minus st, where s is a real or complex parameter. The product is integrated with respect to t, varying from 0 to infinity. If such an integral exists, it is called as the Laplace transform of f of t, denoted by L of f of t. So the name is, it is named after the mathematician and physicist Laplace. So we denote it as L of f of t. So the integral 0 to infinity e power minus st f of t dt, if it exists, is called as the Laplace transform of f of t, denoted by L of f of t. So I told you any definite integral is a function of constant. So here the constant is s, t is the variable. So this definite integral is a function of the constant or the parameter s. So it is also denoted by f of s or f cap of s. So the definite integral, that is Laplace transform of f of t, is denoted by L of f of t or f of s or f cap of s. Now we will get into the operations. So similar to the Fourier transform and Z transform, we have the first one, that is a linearity property. So we have introduced the concept. Now we have to see what happens when two or more functions are taken and added. So let us take two real valued functions, f of t and g of t. Let alpha and beta be the two real constants. So Laplace of alpha f of t plus or minus beta g of t is same as alpha times Laplace of f of t plus or minus beta times Laplace of g of t. So it is similar to the sum rule of differentiation. The derivative of the sum equals sum of the derivatives. Same way, Laplace of the sum equals sum of the Laplace transforms. So you don't have to learn the proof for this. So remember this property, Laplace of the sum equals sum of the Laplace transforms. So you have learned this, the linearity property in Fourier transform and Z transform. Now in particular, if alpha and beta are ones, then Laplace of f of t plus or minus g of t is same as Laplace of f of t plus or minus Laplace of g of t. So if alpha exists and if beta is 0, then Laplace of alpha f of t is same as alpha times Laplace of f of t. Then now we have the transform of some standard functions. So as similar to Z transform, you have Laplace transform of standard functions. The first one is the constant function a. So let f of t be the constant a. So what is the definition of Laplace transform? Integral 0 to infinity e power minus st f of t dt. So e power minus st is the kernel and f of t is a. So integral 0 to infinity a e power minus st dt. So take a out. Integral 0 to infinity e power minus st dt. So what is integral e power minus st? E power minus st by minus s, t varying from 0 to infinity. So take the constant out, minus a by s of, when t takes the upper limit, e power minus infinity, when t takes a lower limit, minus e power 0. So e power minus infinity is 0, e power 0 is 1. So minus a by s of 0 minus 1, that is a by s. So Laplace of the constant function a is a by s, where s is positive. So this condition is very important. So learn the proof and remember by heart the Laplace of standard function with the condition. So Laplace of the constant function a is a by s, where s is positive. So we have seen this in Fourier and Z transform. So e power x is a standard Maclaurin series, 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. It is an infinite series. When x is 0, e power 0 is 1. When x is infinity, e power infinity tends to infinity. When x is minus infinity, e power minus infinity tends to 0. So we have used this in many problems. Now the second standard function is e power at. So Laplace of e power at is integral 0 to infinity, kernel e power minus st, and what is f of t here? E power at dt. So it is same as integral 0 to infinity e power minus of s minus at dt. S minus a is a constant. So the integral is e power minus of s minus at by minus of s minus a, t varying from 0 to infinity. When t takes the upper limit infinity, it is 0. When t takes a lower limit 0, e power 0 is 1. So it is minus 1 by s minus a of 0 minus 1, that is 1 by s minus a. So Laplace of e power at is 1 by s minus a, where s is greater than a. Now similarly, if you replace a by minus a, we have Laplace of e power minus at as 1 by s plus a. So in the same proof, if you replace a by minus a, you have the Laplace of e power minus at as 1 by s plus a. So if you are asked to write the proof of e power minus at, write the proof of second one. In the last step, you replace a by minus a. So Laplace of e power at is 1 by s minus a. Laplace of e power minus at 1 by s plus a, where s is greater than a. Now the fourth one, cos h at. What is cos h theta? E power theta plus e power minus theta by 2. So in place of theta, you have at. So cos h of at, half of e power at plus e power minus at. So take Laplace on both sides. So Laplace of cos h at equals Laplace of half of e power at plus e power minus at. So take half out, split into two Laplace transforms. So half of Laplace of e power at 1 by s minus a plus half of Laplace of e power minus at 1 by s plus a. Take half out and take the LCM. So s minus a into s plus a is s square minus a square, and numerator is 2s. So you have 2 gets cancelled. So Laplace of cos h at is s by s square minus a square, s greater than a. Now similarly, sin h at. What is sin h theta? Half of e power theta minus e power minus theta. So replace theta by at. Sin h at equals half of e power at minus e power minus at. So the proof is similar to the previous one. In place of plus, you have minus in all these steps. So Laplace of sin h at equals Laplace of half of e power at minus e power minus at. Take half out. So split into 2. Laplace of e power at minus Laplace of e power minus at. So what is Laplace of e power at? 1 by s minus a minus Laplace of e power minus at 1 by s plus a. Take the LCM. So a minus b, a plus b, s square minus a square, and numerator, if you simplify, it is 2a. So 2 gets cancelled. So Laplace of sin h at is a by s square minus a square, where s is greater than a. Now the sixth one, cos at. So what is cos theta? Half of e power I theta plus e power minus I theta. So if you take Laplace on both sides, Laplace of cos theta is half of Laplace of e power I theta plus e power minus I theta. In the next step, it is split into 2. Then theta is replaced by at. So Laplace of cos at is Laplace of e power iat plus Laplace of e power minus iat. So what is Laplace of e power at? 1 by s minus a. So what is Laplace of e power at? 1 by s minus a. So here in place of a you have ia. So 1 by s minus ia plus 1 by s plus ia. What is Laplace of e power minus at? 1 by s plus a. So in place of a you have ia. So 1 by s minus ia plus 1 by s plus ia. So take the LCM. So s square minus ia the whole square. So denominator is s square plus a square. Numerator it is 2s. So 2 gets cancelled. So Laplace of cos at is s by s square plus a square, s greater than 0. Similarly, we can find the Laplace of sin at. What is sin theta? 1 by 2i of e power I theta minus e power minus I theta. So sin at is 1 by 2i of e power iat minus e power minus I iat. So take Laplace on both sides. So it is similar to the previous one. In place of plus you have minus. In place of 2 you have 2i. So 1 by 2i of Laplace of e power iat minus Laplace of e power minus iat, that is 1 by s minus ia minus 1 by s plus ia. So take the LCM. So s square minus ia the whole square. So s square plus a square. So when you simplify the numerator, it is 2a, 2i will get cancelled. So Laplace of sin a t is a by s square plus a square, where s is positive. Now the last one, the last standard function is t power n. So far we have seen Laplace of constant function, exponential function, so trigonometric cos a t sin a t, hyperbolic cos h a t sin h a t, and the eighth one is t power n. So start with the definition. What is Laplace of f of t? Integral 0 to infinity e power minus st f of t dt. So in place of f of t you have t power n. So integral 0 to infinity e power minus st t power n dt. So take st as x, so s is a constant, t as a variable. So dx is s times dt. So as t varies from 0 to infinity, x also varies from 0 to infinity. So integral x equals 0 to infinity e power minus x. T is x by s the whole power n. dt is 1 by s dx. So we are rewriting this integral in terms of x. So st is x. What is t? X by s the whole power n. dt is 1 by s dx. Now group take the constant out. The constant is s power n plus 1. So 1 by s power n plus 1 integral 0 to infinity e power minus x, x power n dx. So this integral is same as gamma of n plus 1. This integral is nothing but the definition of the gamma function, that is gamma of n plus 1. So Laplace of t power n is 1 by s power n plus 1 into gamma of n plus 1. So we and you also know that gamma of n plus 1 is same as n factorial. So there are two formula for Laplace of t power n. If n is a positive real number, you have to make use of this formula. If n is a positive integer, you have to make use of n factorial by s power n plus 1. So you should learn the proof of all the standard functions, and you should by heart the Laplace of all the standard functions. So I have covered 1 to 9. Now we will look into problems. Find the Laplace transform of the following. So first one, 4. So 4 is a constant function. So Laplace of 4 is 4 by s. Second one, Laplace of 6 e power minus 4t. Take 6 out. 6 times Laplace of e power minus 4t. So what is Laplace of e power minus 4t? 1 by s plus a. So 1 by s plus 4. So 6 times 1 by s plus 4. So 3 e power 3t. So take 3 out. So 3 times Laplace of e power 3t. So 3 times 1 by s minus 3. Next we have cos h square 3t. See, there is cos h square is not a standard function, but cos h theta is a standard function. Cos h at is a standard function, but cos h square is not a standard function. So whenever you have cos h square or sin h square, make use of the formula. What is cos h theta? Half of e power theta plus e power minus theta. So what is cos h 3t? Half of e power 3t plus e power minus 3t. So square both sides. So it is 1 by 4 of a plus b whole square, a square e power 60 plus b square e power minus 60 plus 2ab. So 2 into ab, that is 2 times e power 0, that is 2. So now you take Laplace on both sides. So Laplace of cos h square 3t, 1 by 4 you take it out, split into 3 Laplace transforms. So Laplace of e power 60 plus Laplace of e power minus 60 plus Laplace of 2. So what is Laplace of e power 60? 1 by s minus 6. What is Laplace of e power minus 60? 1 by s plus 6. And what is Laplace of 2? 2 by s. So this completes the solution. Now next one, 2t square minus t plus 4. So take Laplace, split into 3 Laplace transforms. So this is true by linearity property. So 2 times Laplace of t square minus Laplace of t plus Laplace of 4. So you have integral powers of t. So what is, if you have n as an integer, if you have integral powers of t, you should make use of the formula n factorial by s power n plus 1. So Laplace of t square 2 factorial by s cube. Laplace of t 1 by s square. Laplace of 4 4 by s. So this completes the solution. Now next we have sin a t sin b t. Now see, you have some rule to be true in Laplace, but product rule is not true in case of any transform. Whether it is Fourier transform or Z transform or Laplace transform, you don't have product rule. So you cannot write Laplace of sin a t sin b t as Laplace of sin a t into Laplace of sin b t. That is wrong. So whenever you have cos A sin B or sin A sin B, cos A cos B, you have to make use of the formula. So what is 2 sin A sin B? Cos of A minus B minus cos of A plus B. So sin A t sin B t is half of cos of A t minus B t minus cos of A t plus B t. So it is half of cos of A minus B t minus cos of A plus B t. So take Laplace on both sides. So half Laplace of A minus B t minus half Laplace of A plus B t. So what is Laplace of cos A t? S by s square plus a square. So in place of a t, you have a minus b t. A minus b and a plus b are constants. So what is Laplace of cos a t? S by s square plus a square. So in place of a, you have a minus b. So s by s square plus a minus b whole square. And here s by s square plus a plus b the whole square. So simplifying, take the LCM and simplifying, you have the numerator to be 4ab. So the answer is 4abs by 2 times the product of the denominators. So I repeat, whenever you have cos A, cos B, sin A, sin B, sin A, cos B, you cannot use product rule. There is no product rule in case of transforms. So you have to make use of the formula depending on the product. So 2 sin A sin B is cos of A minus B minus cos of A plus B. So we find the Laplace of the product sin A t sin B t using this formula. Now next we have A power 2t. See, A power 2t, whenever you have A raised to something, whenever you have constant term raised to the variable t, remember, whenever you have constant term raised to the variable t, write it as e power log of that term. I repeat, whenever you have constant term raised to the t, raised to the variable t, express it as e power log a power 2t. So e power t times 2 log a. What is log m power n? N log m. So e power t times 2 log a. So what is Laplace of e power a t? 1 by s minus a. So Laplace of e power t into 2 log a is 1 by s minus 2 log a. So what is Laplace of e power a t? 1 by s minus a, where a is a constant. So what is a constant here? 2 log a. So 1 by s minus 2 log a. Now next we have 3t plus 4 the whole square plus 5 square. So expand this, 9t square plus 24t plus 41. Take Laplace on both sides. So split into 3 Laplace transforms. So you have integral powers of t. So 9 times Laplace of t square. So 9 into 2 factorial by s cube. 24 times Laplace of t. 24 into 1 factorial by s square plus Laplace of 41, that is 41 by s. Now next we have 3 root t plus 5t power minus half. So let f of t be 3t power half plus 5t power minus half. So whenever you have rational powers of t, you have to make use of gamma function. See, there are two formula for Laplace of t power n. When you have integral powers of t, make use of the formula n factorial by s power n plus 1. When you have rational powers of t, make use of the formula gamma of n plus 1 by s power n plus 1. So, f of t equals 3t power half plus 5t power minus half. So, what is Laplace of t power n? 1 by gamma of n plus 1 into s power n plus 1. So, when you have rational powers of t, Laplace of, you can make use of this formula 1 by gamma of n plus 1 s power n plus 1. So, if you take n as half, Laplace of t power half is 1 by gamma of 3 by 2 into s power 3 by 2. What is 3 by 2? Half plus 1. So, what is gamma of n plus 1? N times gamma n. So, whenever you have the 2 in the denominator, whenever you have a rational expression with 2 in the denominator, you should reduce it to gamma half. So, you have learned this in first year. Whenever you have gamma 3 by 2, gamma 5 by 2, gamma 7 by 2, you have to make use of this formula to reduce it to gamma half. So, 3 by 2 can be written as half plus 1. So, 1 by gamma of half plus 1 s power 3 by 2. So, what is gamma of half plus 1? Half gamma half. So, half, what is gamma half? Root pi. So, half root pi s power 3 by 2. So, it is same as 2 by root pi s power 3 by 2. So, Laplace of t power half is 2 by root pi s power 3 by 2. Then, if you take n as minus half, so Laplace of t power minus half, you take n, you substitute n as minus half in this formula. So, s power minus half plus 1 by gamma of minus half plus 1. So, s power half by root pi. What is the denominator gamma half, which is same as root pi. So, s power half by root pi. So, the Laplace of the first term is 3 times s power 3 times 2 by root pi s power 3 by 2 plus 5 times s power half by root pi. So, I forgot to write 5 here. So, remember, whenever you have rational powers of t, you have to make use of gamma function formula, that is gamma of n plus 1 by s power n plus 1. Now, the next one, t power minus 3 by 2 plus t power 7 by 2. So, I will discuss this in the next video.